We are looking at 5-6 notes and using the quadratic formula, which should be reviewed, but you might not. But let's intro it with an idea. So we have solved quadratics a couple ways. One, we solve quadratics by graphing, finding the x-intercepts. We solve quadratics by taking square roots. We solve quadratics by completing the square, which uses square roots. We solve quadratics by factoring in zero product property. This is the fifth and final way to solve quadratics, and it is called the quadratic formula. So no matter what is thrown at you, you can always use the quadratic formula. It just might not be the fastest way, but it solves every quadratic. So the first thing I have here is just consider solving this x squared minus 81 by factoring. Well, isn't this set equal to 0? And it's a difference of squares, right? So factor it. It would be x what? Plus 9 and x minus 9, but it equals 0. So zero product property says one of these two things has to equal 0. So x would equal what to make this 0? If x was negative 9, and x would be what to make this 0? Positive 9. So I solved it by factoring. Now, because there's no bx term here, there's no middle term, I could also solve it by using square roots. To solve this by using square roots, I'd want to isolate the square by adding 81. You cannot take the square root of addition and subtraction. And so I'd get x squared equals 81, and then how do I get rid of the square? Take the square root. Now, how many answers should I get when I take the square root? 2, because 9 squared gives me 81, and so does negative 9 squared. So we get the same answer, but we don't want to forget that plus or minus sign. Okay, now look at the next one. It says to solve by factoring. Well, I'm having an issue here. X squared minus 7 equals 0. There's no GCF, and there's no factors of 7, negative 7, that add up to 0, because negative 7 and 1, and that's it, right? Okay, if I was told to solve this by factoring, this is a little bit different. If you think about what we did to get the difference of squares here, we took the square root of x and we put it here and here, and we took the square root of 81 and we put it here and here, right? So watch me do that again. I'm going to say x times x is going to be x squared. I need one positive and one negative. Agreed? And then it would be the square root of 7. But since there is no nice square root of 7, I'm just going to leave it like this. And if you think about what we did when we worked with square roots earlier in the year, this would be x negative x squared of 7, and this would be positive x squared of 7, which would cancel to 0. And the square root of 7 times the square root of 7 would make the square root of 49, which is 7. So if I asked you to solve this, x would equal a negative square root of 7, or x would equal a positive square root of 7. So that's a little bit different. I wouldn't typically factor this as a difference of squares, but it truly works if we follow that pattern. Now, solving it by square roots would probably be more up our alley. We would add the 7, and then we would come in and take the square root. But the mistake I get all the time is kids telling me it's the square root of 7. Every time I solve, I'm asking you what squared equals this. It should be a positive or a negative. Okay, do you see the connection there? So yes, I can solve by factoring and I can solve by square roots on some of them. But I can't solve everything by factoring, and solving by square roots doesn't work if I don't have the right numbers, if I have an x term there. So we have this thing called the quadratic formula. Now, in order to use the quadratic formula, I want my standard form of a quadratic. So we've learned several methods, like I said, graphing, using tables to help us graph, factoring, using square roots, completing the square. And then this is the last method. It's the quadratic formula, and it's always going to work. So we want it to be in standard form. Ax squared plus bx plus c equal to 0. Why can't a be 0? Well, what happens if a is 0? What happens to your quadratic? It's not a quadratic anymore, right? Because x squared is gone. So a can't be 0. And we use this formula to find the roots. Now, if I cover this up, does anybody recognize this x equals negative b over 2a? What was that? X equals negative b over 2a. We used it. Axis of symmetry. Yep, axis of symmetry. So we already know that part. Look at the plus or minus sign. It's built in, because you know how when we take a square root, you get a positive or negative? It's built in there. Okay, so let's get to using this. Now, first example, I'm asking you to find the zeros, and I'm going to get this in a little bit tighter here. Is it still in focus? We good? Okay. So I'm asking you to find the zeros of f of x equals x squared plus 10x plus 2. You couldn't solve this using square roots unless you completed the square. It won't factor. Factors of 2 I can't factor it. So I'm going to jump to the quadratic formula. First thing is you want to set it equal to 0. So guys, we are still finding x. Find x when y equals 0. So that's why we're setting f of x equal to 0. And here is my formula. This is the template that we want to use. So here's what I would do until you get comfortable with it. I replace every variable with parentheses, and I replace this one too. So the opposite of b, plus or minus, all of this goes underneath the square root sign, parentheses, b squared minus 4 times a times c all over 2a. So I like to template it and put my numbers in. So in our problem, what's the a value? 1. What's the b value? 10, and c is 2. If it's not in standard form, we want to put it in standard form with the ax squared plus bx plus c. Okay, this is the template that you want to keep using, and then I'm going to plug the numbers in. So it's the opposite of b, so negative 10 plus or minus b squared minus 4 times a is 1, c is 2, all over 2 times a, and a is 1. Now, here's what I want you to focus on. I want you to focus on 3 pieces. So you're probably going to want your calculators. You could use your brain. These 3 pieces are right here. Here's one piece. What's underneath the square root sign and the denominator? So I'm going to template this next idea. It is going to be x equals negative 10 plus or minus something all over 2. So I did the quick things. I got my sign cleaned up. I kept my plus or minus. I kept my square root. And 2 times 1 is 2. I want to put this in the calculator or use my brain. I'm fine with using my brain. Brain's a good tool to have. If I put this in my calculator, oh, my battery is low, guys. I'm not putting the square root sign. I'm only going to put this in. So parentheses, 10, close them, square it. Minus 4. You can use a times symbol. I'm just going to use parentheses. That's all I want. I want to know what's underneath the square root sign. And that number is 92. Are we okay with that? Okay, why am I not putting the square root sign in there? Well, if I put the square root sign in there, and I have the number in there, I'm going to get this decimal, and I don't want that. I want exact answers. Also, you will only be able to use this calculator on your test. You will not be able to use this one because of the roots. So just like before. Got it? So we're only using this one. We're not able to use this one. So get comfortable doing it in this calculator. So I don't want the square root sign. I want to know what goes under it, which is 92. So I've got these 3 pieces to my problem. And now we're going to do a little bit of work with roots. So I'm going to keep that negative 10 plus or minus all over 2. But I need to break up the square root of 92. That's what we're doing now. So you can do it off to the side. Totally up to you, but that's my focus. So what is the square root of 92? What perfect square goes into it? Now that might take a little bit of work. Anybody? It's 4. 4 is the perfect square. So that 92 is a little bit bigger. 4 is the perfect square, so how do I break this down? 2 square roots of 23. So we're going to use our old skills of breaking this down and getting the biggest perfect square. And now I want you to look at the 3 pieces that you have. You have a negative 10, you have 2 square root of 23 all over 2. Do all 3 pieces have something in common that we could reduce the fraction? They all have to divide by 2. You can't just divide part of it. So divide each piece by 2, and we are left with negative 5 plus or minus 1 square root of 23 all over 1. So there's my answer, x equals. If you wanted to see it written out, it'd be negative 5 plus or minus 1 square root of 23 all over 1. I just simplified it up there. Okay? So the new part is putting it in the formula and then solving it. We're going to use our old skills to break down our roots, and we're going to use our rules that they all have to reduce at the same time. All right, we're going to do that same problem, but we're going to complete the square. So we should not forget how to complete the square. In order to complete the square, I want to get rid of c by subtracting it. It's going to be x squared plus 10x. Leave a little room, equals -2. And then what do? Why do I leave a little room? So we can actually complete the square, right? So what was the rule to complete the square? A has to be 1. And what do I do to get this number? I'm going to take b, which is 10, divide it by 2, and square it. So 5 squared is 25. I'm hoping we remember this. Completing the square is an easy thing to forget, but we should just be able to refresh it and get it. Okay, factor this, double check. It's x plus 5 times x plus 5. So quantity squared equals 23. And then how would we finish solving this? We would take the square root of both sides. I'm left with x plus 5 equals, now I took the square root, so what do I want here? Plus or minus. And can I break down that 23? Nope, so we're stuck with it. And then how do I finish this problem? Subtract 5, and guess what I get? -5 plus or minus the square root of 23. Same answer I got with the quadratic formula. Okay, so that is in comparison. We can solve this problem in 2 ways, but we're using the quadratic formula today. So the directions say, find the zeros. What's another word I could use instead of zeros? Find the x-intercepts or the roots, or just solve the quadratic. And we're solving it using the quadratic formula. So try to write down the quadratic formula real quick. So quadratic equation, y or f of x equals ax squared plus bx plus c. That's the quadratic equation in standard form. The formula is what solves it. So without looking up, can you write down that quadratic formula? X equals -b plus or minus. And this is what's new, that square root of b squared minus 4ac all over 2a. So you already know part of it. We just got to get that part memorized underneath the root. All right, first things first, set this equal to 0. You don't have to, but I'm going to go ahead and pull the a, the b, and the c. So a is 1. What's b? -8, and c is 10. Okay, you don't have to do it this way, but I'm going to. I'm going to template my quadratic formula and replace everything with parentheses, and then I'm going to plug my numbers in. For some people, this really helps them so they don't mix things up. But if you're comfortable with it, you can throw the numbers in as you go. So while you're working, I'm going to toss the numbers in. Notice it's the opposite of -8. And this has to be in parentheses to square it. And don't get comfortable, the a is always 1. It can be different. All right, so then we're going to focus on those 3 pieces. 1, what's underneath the root, and what's in the denominator. So I like to clean up the easy stuff so I don't lose it. See how I just cleaned that up? And then I'm going to figure out what goes under here. Now, I can use my brain, guys. That's 64 minus 40. I get 24. If I want to put it in the calculator, remember we're not putting the root in the calculator. So it is going to be parentheses -8 squared minus 4 times 1 times 10. Again, I don't have to put the whole thing in. I could use it for what I need, but I do want to get the right answer. So I'm double checking myself. I got 24. Okay, we have these 3 pieces. What I need you to understand is I can't reduce the 8 and the 2 because that 2 also belongs to square root of 24. Can I reduce the 24 and the 2? No, because that's a square root and that's not. Do you remember all those rules? So I'm going to leave this 8 plus or minus something all over 2, and I need to break down that square root of 24. So what is your perfect square going into 24? What's a perfect square that divides into 24? 4 times 6. So this should be 2 square root of 6. What's underneath the root sign is locked in. We can't break it down. We can't reduce it anymore. And so now I'm going to go through and I'm going to reduce the 8, the 2, and the 2. Now, maybe this is like a 4 down here. It doesn't always just disappear. But in this problem, we end up with 4 plus or minus the square root of 6 all over 1. So everything here divided by 2. That's my answer. Now, if I want to check this answer just like before, I'd probably put this in the calculator, 4 plus the square root of 6, get the decimal, and check it to see if it works, and it'll be really close to 0. Okay, that is your quadratic formula. Now, look at this next one. Same idea, right? So I'll give you a minute. Go ahead, set this equal to 0. Here is your formula. Here's your template. Plug it in and get me those 3 pieces. All right, so this problem, you can pull your A, B, and C. Again, I like to use the parentheses here so I see that that's an extra negative sign. Negative 1 squared minus 4 times 2 times C is 2 all over here. So get these 3 pieces here. We end up with x equals 1 plus or minus the square root of something all over 4. That something should end up being a negative 15. Do you agree with me? Yes? Negative 1 squared is 1 minus 16. Guys, I'm not distributing this 4. It's 4 times 2 times 2, and that's where I'm getting 1 minus 16, which is negative 15. Okay, now, this means no real solutions. So whenever you do the no real solutions, we're still going to have to deal with this. Can you leave me the square root of a negative? No. So it is going to be x equals 1 plus or minus. Well, this would break down to be the square root of negative 1 and the square root of 15. What's the square root of negative 1? I. We keep that out front, keep the square root of 15 all over 4. I have 3 terms, none of them reduce, so that is my final answer. And notice I got an imaginary number. So this is my complex number, A plus BI type idea. Okay, now we have another one here to find the zeros using the quadratic formula. So go ahead and attack that one. All right, so we are going to set this equal to 0. Pull your A, your B, and your C. If it helps you show that. A is 3, B is negative 1, C is 8. And then plug in your quadratic formula. Again, you can template it out. I'm just going to throw it in there because I'm comfortable doing that. But whatever works for your brain and whatever helps you get it right. All over 2 times 3. Okay, so I want to get these 3 pieces here. It's really important to watch that negative. It's always the opposite of B, so that's where I got the positive 1, plus or minus. I believe we get the square root with a negative 95 underneath it. Agree? Okay. And it's still all over, but it's over 6. So the square root of a negative cannot be left in your answer. We're going to turn that into an imaginary number, and that would be 1 plus or minus I square root of 95. Why am I leaving the 95 there? There's no perfect squares that divide into it, but you should have tried to break it down. Over 6, that is my final answer. Now, you might also see the answer written as 1/6 plus or minus I square root of 95 over 6. I don't need to break it down that way, but that is the equivalent answer. But that's why I can't reduce. Like if this was a 2 and a 6, I can't reduce that because a 6 belongs to both of these. Okay, now we're going to change gears, and we're going to talk about something called the discriminant. Okay, the discriminant, it's spelled exactly as it sounds, discrimin, and then A-N-T at the end. So the discriminant is part of the quadratic formula that you can use to determine the number of real roots in an equation. So the discriminant is the part of the quadratic formula that's underneath the square root. So the discriminant is the b squared minus 4ac. So notice I'm saying it's under the square root. So if I ask you for the discriminant, which I will, you don't include the square root. It's the number underneath the square root sign. Okay, now let's think about this. This says, it might be hard to read on here, b squared minus 4ac is greater than 0. What kind of numbers are greater than 0 if we had to generalize that? Positive numbers. So if your discriminant is positive, you're going to get two distinct real solutions. Because we can take the square root of a positive number, right? Like the square root of 36 is 6. And if you think about it, we would get negative b plus that number, which is one solution, and negative b minus that number, which is the second solution. So we'll get two real solutions. Now, what if your discriminant is actually 0? Well, what happens when I take the square root of 0? I get 0. And if I add 0 and subtract 0, does that change my outcome? So I'm only going to get one solution. It's where the vertex bounces off of the x-axis. So we have one x-intercept. We get one distinct real solution. What about when the discriminant, b squared minus 4ac, is less than 0? What kind of numbers are less than 0? Negative numbers. And I want to make sure you're paying attention to this so you understand. This shouldn't be a memorization. It should be a I understand. When I have a negative number underneath the square root sign, I'm going to have an imaginary number, right? So how many real solutions do I have? I have no real solutions. I have two complex solutions, or you could say two imaginary. So if you think about this, if your quadratic never crosses the x-axis, whether it's up here or it's down here, that's when I have those imaginary solutions. If your quadratic just bounces off on the vertex, that's when I have one solution, and here's infinite. Okay, now I'm going to take this one step further. If I have a perfect square, I will have two rational solutions. As in, if I take the square root of 49, I get positive and negative 7, right? I take the square root of 100, I get positive and negative 10. So I will have fractions or decimals, but they will be rational numbers. If it's not a square root, if it's a non-perfect square, it's not a perfect square, I will get two irrational solutions. So if I have a positive outcome, I'll get two solutions. If they're perfect square discriminant, I'll get two rational. If it's not a perfect square, I'll get two irrational. So let me show you real quick. If we go back to this first example, I had the square root of 92. Is 92 a perfect square? No. If I plug this in the calculator even broken down, I will get a decimal. And it will be an irrational number because that decimal will not repeat and will not terminate. Okay? Same thing here. Irrational number because the square root of 6 doesn't break down nicely. All right, if I have the one real solution, isn't 0 a perfect square? So I will always have one rational solution. So it will be real, but it will be rational. And these will be neither rational or irrational because what are they? They're imaginary. Okay, so let's take this and set these up. Now, the first thing I need to do when I'm solving any problem by the quadratic formula is set it equal to 0. The same is true for the discriminant. So the discriminant is b squared minus 4ac. That's my discriminant. And when I set this up, I want the ax squared plus bx plus c to equal 0. So we need to set this equal to 0 by adding the 7, x squared minus 6x plus 7 equals 0. Okay, did I ask you to solve and find me the solutions? Nope, the directions say find the type and number of solutions. Okay, so b squared, negative 6 squared minus 4 times 1 times 7. So we're looking at that number that goes underneath the square root. All right, you want to use a calculator, use a calculator, but use parentheses. We should end up with what? 8? Do we agree with 8? All right, so my discriminant is 8. Now, that doesn't tell me the solution. It just tells me my discriminant is greater than 0, So I'm going to have two distinct real solutions. Would they be rational or irrational? Is 8 a perfect square? Nope. So I would have two distinct real solutions. It would be irrational. Guys, the idea of them saying distinct solution is you have two different solutions. Okay, look at part B. First, I want to set it equal to 0 by adding 9. Then I'm only doing the discriminant. So negative 6 squared minus 4 times 1 times 9. All right, tell me what you get out. Should be 36 minus 36 if you have your signs right, which is 0. So my discriminant is 0. So the discriminant's 0. I will have one distinct real solution, and it will be rational, because the square root of 0 is 0. I'm only going to have one answer because adding, subtracting 0 doesn't change it. Okay, set this equal to 0 by adding the 11. Got to do that first step right. Find me the discriminant, negative b squared minus 4 times a times c. Get me that value. Well, it's 64. Or not, yeah, at 36, sorry. 36 minus 44, we should get negative 8. So my discriminant is less than 0. It's a negative outcome. Can I take the square root of a negative number? Nope. So I will have 0 distinct real solutions or no distinct real solutions. What will I have? 2 imaginary, or you could say 2 non-real solutions. Okay, bear with me. We're almost there. Take a minute and read example 4. We've seen problems like this before. So our formula for this is y equals negative 16t squared minus 2t plus 500. Y is the height in feet that the water is above the ground. Okay, so not the height of the helicopter, but the height of the bucket. T stands for the seconds after it's released. So we're looking for how high are we, and we're going to release the water. How long does it take to hit the ground? And you know the water is not just dropping unless the helicopter is hovering. The helicopter is moving, the water is going to be moving at an angle. Okay, so it says the speed of the helicopter is 91 feet per second. Let x be the horizontal distance from the fire. Okay, so the 91 feet per second is 91 feet per second times t, which is seconds. So that is going to give us the horizontal distance. At what horizontal distance from the fire should the pilot start releasing the water? Remember, an object in motion stays in motion, right? So the helicopter is moving at 91 feet per second. What is the water moving at? 91 feet per second, and then it releases it. Okay, so the water is not just dropping straight down. It's going to have that little bit of an angle on it. So we need to find out when they're going to release it. So here's what we're going to do. We're going to take, it says use the first equation to determine how long will it take for the water to reach the ground. We're not putting these equations together. We're going to solve for t. And once we find t, we're going to plug it in to see how fast, what the horizontal distance is using that speed. Now, solving for t is not easy because we have t squared and t. So when does the water hit the ground? When the height is what? 0. So we're going to set our equation equal to 0. Nothing's changing except we're replacing the y value with 0. Just like you kick a ball, and when does it hit the ground? It hits the ground when it's 0 feet high. You're on a building and you drop a penny. When it hits the ground, it's 0 feet high. The raft is being released into the water. When it hits the water, it's 0 feet high. Okay, so we're setting equal to 0. But instead of trying to factor this or complete the square, we're going to use the quadratic formula. So we are trying to find t. So in our case, t equals negative 2, that's b, plus or minus the square root of b squared minus 4 times a is negative 16 times c is 500. 100% using a calculator on this one, all over 2 times a. So you're going to go in and use your calculator and get these pieces. Same thing. We have t equals t2 plus or minus something all over negative 32. Okay, I would use a calculator, type this in. watch, this should be a positive 4. A negative times a negative is going to be a positive number. We should get 32,004. That's what we should get, 32,004. Okay, the good news is this is a word problem, so I'm okay with you getting me a decimal. So I want the average time, and as I say average, the approximate time. Now, if I go to type this in the calculator, you can do what you want. If I type it in like this, 2 plus the square root of 32,004, I'm going to hit enter. That is my numerator, approximately 180.897 all over negative 32. And then I'm going to divide by my negative 32, which gives me negative 5.65. Okay, so approximately negative 5.65. Does that answer make sense? Because we're talking about time. It does not make sense. So I'm going to throw that answer out, and I'm going to do this problem again, but instead of doing 2 plus it, what am I going to do? I'm going to do 2 minus it. Now, if I want to do it this way, and I go 2 minus the square root of 32,004, here's what I need you guys to see. First of all, if I do this, do you see that I'm still underneath the square root sign? So be careful with that. If I do this, I'm going to get it wrong. Do you understand why I'm going to get it wrong? My calculator is going to divide and then subtract it from 2. So if you're going to put it in like this, you need to get the answer and then divide by negative 32, and I get 5.53. That is the correct answer. Now, I'm just going to throw this out there. If you want to put it in as a fraction, you got your second, you got your fraction key. You could type it in all at once. Get out of there, go to the denominator, divide by negative 32. You will get that same answer. But you either have to put it in as a fraction or do it as 2 different steps, okay? All right, what did we get here? I got negative 176.897 divided by negative 32, and that was approximately positive 5.53. And so 5.53 seconds for what to happen, guys? For the water to hit the ground. We have no idea where it landed. We just know it's going to take 5.53 seconds to hit the ground. So what is the horizontal distance that it will travel? So picture the helicopter up in the air dropping the water and the water sort of trailing back there. What's the horizontal distance? So the horizontal distance x is found by taking 91 times the time, which is 5.53. Now you want it to be more accurate, use more decimal places. But I'm taking 91 times 5.53, and I'm getting that x is approximately, I have 503.23. So 503.23 feet. And that is the horizontal distance. Okay, the water will travel at a horizontal distance about 503 feet. Therefore, the pilot should start releasing the water when the horizontal distance between the helicopter and the fire is 503 feet. So if it's going to take that long, that's when they need to release it. Okay, another problem here. It says the pilot's altitude decreases. Which changes the function to describing its height to here? So do you see the difference here? The original function was negative 16 t squared minus 2t plus 500. Everything's the same, but he dropped his altitude by 100 feet. Okay. To the nearest foot, what is the horizontal distance the target should begin releasing the water? So we are going to set it equal to 0 again. We are going to put it in the quadratic formula. We are going to find x, and it's still going the same speed. So once we find x, we are going to plug it in. So I'll give you a minute to do that. All right, I plugged everything in, so you can always pause this recording. I have 2 plus or minus. My number under the square root is 25,604. I went through, I added it, and I got negative 5.06. I subtracted, I got 4.94. So the time is 4.94 seconds to hit the ground, and that means the horizontal distance would be 449.5 feet approximately. All right, the next page is a graphic organizer for you. It shows the 5 ways we've solved quadratics. So the first method is graphing. And when you're graphing, you're looking for the x-intercepts. That shows you where the solutions are. So they showed you that problem with graphing. If you're factoring, we want to set it equal to 0. Factoring is the same as saying use the 0 product property. So I'd add these little terms in there. 0 product property. So if you're told to solve using factoring or solve by the 0 product property, set equals 0, factor completely, but don't forget to actually solve for those values. Solving using square roots will only work if you have x squared or a quantity squared. You want to break down your roots. Don't forget the plus or minus that goes with your square root. Solve by completing the square. The rule is that a has to be 1. And if b is an even number, it's easier, but doesn't have to be. So once a is 1, you are going to do b over 2 squared. That is the rule to complete the square, and that is the number that goes in both of these boxes. They didn't break it down. There would be 9 that goes in there. Factor it and solve using roots. And the last way is your quadratic formula. And if you want to take a second, maybe you write down your quadratic formula here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. They gave you an example, but that is the general formula. And then the discriminant. What does the discriminant tell you? Type of solutions and number of solutions. Okay, so I'm going to add that there. If your discriminant is negative, well, the discriminant is b squared minus 4ac. So if it's less than 0, you have no real solutions, but what do you have? 2 imaginary. If your discriminant is 0, I'm just repeating what we already have in our notes, you will get 1 real solution, and it will always be rational. And if your discriminant is positive, which means greater than 0, you'll get 2 real solutions. And then that 2 real solutions can break down. If it is a perfect square, what happens? It is going to be rational. 2 rational answers. If it's not a perfect square, it will be irrational. So if you're asked to find the number or type of solutions, you're only finding the discriminant. If you're asked to solve, then you're using the quadratic formula.